Okay guys, welcome back. So in this video I'm going to proceed with the second example on even function. Okay, so now consider this following predict function of fx. So as you can see here, you have four functions: this one, second one, the third one, and the last one. Remember, this is not a function that you need to sketch. Okay, you just have to sketch whenever you have a range here. Okay, so this is not included in sketching. This one is for you to know the predict function of this fx. Okay, so as you can see here, you have two constant, 1 and 1, and another 2 here is in terms of variable x. So you need to construct a table of coordinate for function 2 and for the third function here. Okay, so for the second function here, I consider the value of x -1 and another one is 0. Okay, so for this range, my fx is equals to -x minus 2. So substitute -1 into here will give you -1. Substitute 0 into here will give you -2. So therefore you will have these 2 point of coordinate. Okay, for the third function, I consider two value of x, which is 0 and another one is 1. So 0 and 1. So what is your fx for this range? Your fx is equals to x minus 2. So that's why here fx is equals to x minus 2. So again, substitute 0 into here will give you -2. Substitute x is equals to 1 will give you -1. So you will have another 2 point. Okay, so now we are going to sketch the graph. Okay, you cannot start with this point. Okay, you need to refer back to your predict function here. Your first function is this value 1. So between -2 until -1, your fx is always equals to 1. So therefore you will have the horizontal line. Okay, so from here, -2, -1. So your fx is equals to 1. Okay, so now for the second function, so refer to these 2 point. For the third function, refer to another these 2 point. Okay, so for the second function, you have a point of -1, -1, which means x is equals to -1, fx is equals to -1. So therefore, you will have a point here. Okay, the second one is 0, -2. So x is equals to 0, fx is equals to -2, right here. Okay, so you know that you will have this line. Okay, so the next one is the third function here. So you need to consider these 2 point, 0, -2. So x is equals to 0, which is here. Fx is equals to -2. So you will have a point here. Okay, another one is 1, -1, which is right here. Okay, so therefore you will have another line here. Okay, and the last one is this one. Between 1 and 2, your fx is always 1. So therefore you will have another straight line here. Okay, so if I number, so this is the first function. Second one, sorry, so sorry, so this is -1. You just consider it to be straight. Okay, so this is my second function, third one, and the last one. Okay, So now the function will repeat itself, okay, after the period of 2l. So in this case, your 2l is equals to 4. 1, 2, 3, 4. So after this period of 2l, so the function will repeat itself. Okay, so you need to start again with 1. Okay, so this is your last point for the last function, so therefore it will be the first point of the new function. So as you can see here, this is a straight line, so therefore you will have a straight line here, 1. Okay, so the next one is, if you want to do the dotted line, so this will be your dotted line. Okay, stop here, so this is your new point. Okay, and another one is here. Okay, so take a look at this one here, from -1 until 0, so the range here is 1. So that's why we consider from 3 until 4. Okay, so therefore you will have another line here. Okay, so are you going to continue until you get the complete set of graph on your right hand side? No, you need to stop here. Why? Because the question asks you from -4 until 4. So at this point your x is equals to 4, so that's why you stop until here. Okay, so you won't have the complete set of graph. Okay, so for the left hand side, so you need to start with number 4, 3, 2 and 1. So number 4, you will have a straight line, so this one you start with here. Okay, so therefore you will have, so the range is 1, so you will have the straight line. Okay, for the third function here, as you can see, it start when your fx is -1, so down here. Okay, so as you can see here, you have this kind of line, this one, so therefore you will have here until here, the range is 1. Okay, so you will have one point here and another one is here, so you will have this line. Okay, so then we stop. You already sketch from -4 until 4. Okay, so -4 until 4. So when you are going to decide whether the function is odd, even, or neither function, you can just focus on the original graph here. Okay, the complete graph here. So as you can see, again it is symmetrical about fx axis. Okay, so therefore this is an even function. Why? Because it is symmetrical about fx axis. Okay, so when you know this is an this is an even function, so must come to your mind is that your bn is equals to 0, and you are going to integrate from 0 until l. Okay, 2 over l from 0 until l. Why? Because it is symmetrical about fx axis, so you can just consider the positive part here. Okay, because the graph on your left hand side is just equal on your right hand side. Okay, so now we are going to find the Fourier series coefficient and also Fourier series expansion. Okay, so Fourier series coefficient refer to A naught, An and Bn. Fourier series expansion is your fx. Okay, So first step is to define what is your L. Okay, so as you can see here, your L is equals to 2. Okay, so you know that your L is equals to 2. So by using this formula here, so your A naught is equals to, so 2 over L, so your L is equals to 2. So integrate from 0 to L, so from 0 to 2, fx dx. So this one you can simplify. So you end up with integrate 0 to 2 fx dx. Okay, so now take a look here. You need to integrate. Your lower limit is 2, your lower limit is 0, your upper limit is 2. So by looking at this range here, you need to identify where is the point, what is the function which represent your x is equals to 0. Okay, and another one is x is equals to 2. Okay, so by looking at this function here, you should consider the last two function. Okay, because x is equals to 0 is in this range. X is equals to 2 is in this range. Okay, or you can take a look at this graph here. Okay, remember previously I told you we are going to consider the positive part. Okay, since it is symmetrical. Okay, so you are considering from 0 until L. Your L is equals to 2 here. Okay, so from 0 until L. So take a look at this one here. So the only function that will be considered is the third function and the last one. Okay, so therefore you are considering this function and this function. Okay, you get it? So that is why we will only choose this function. Okay, so in this case, the lower limit is 0, the upper limit is 1. So what is the function for this range? Fx is equals to x minus 2. For this range, the lower limit is 1, the upper limit is 2, your fx is equals to 1. Okay, so therefore you need to split the interval here, you need to split the limit here, you need to split the limit here into two functions. Okay, so therefore you will have your A naught is equals to, so the first function will be, so integrate from 0 to 1. So what will be the function? X minus 2 dx plus 1 to 2. So the function is 1 dx. Okay, so integrate this one will give you x squared over 2 minus 2x. So the upper limit is 1, the lower limit is 0, plus x. Okay, so now we will consider upper limit minus lower limit. So remember, this one represent upper limit. Okay, and this one is lower limit. So it should be upper limit minus lower limit. Okay, so therefore your A naught is equals to, so the first one, for the first function here, when you substitute x is equals to 1, so you will have 1 over 2 minus 2 minus 0. Okay, plus 2 minus 1. Okay, So your answer should be, so 1 over 2 minus 2 plus 1 is equals to negative 1 over 2. Okay, so therefore this is your A node. Okay, so for your AN here, okay, for you to calculate your AN, you just have to use this one, but you need to multiply by cos n pi x over L. Okay, so therefore you will have your AN is equals to, so integrate 0 to 1 x minus 2 cos n pi x over 2 dx plus 1 until 2. So this is 1 multiplied by cos, then you will have cos n pi x over 2 dx. Okay, so remember here, this one we already cancel out to be 1, so that's why you don't have any value up in front here. Okay, so now for this function, you need to apply tabular method because you have a combination between polynomial polynomial and trigonometric function. Okay, as for this one, this is direct integration. Okay, so we settle out the tabular method first. So you will have, you need to differentiate. So you need to differentiate x minus 2, and you are going to integrate cos n pi x over 2. Okay. So differentiate x minus 2 will give you 1. So integrate cos will give you sine n pi x over 2 divide by, so differentiate the argument inside here will give you n pi over 2. So if I rewrite it, so I can just rewrite as 2 over n pi. Okay, so the last one here, this is plus 0. So integrate sine will give you negative cos n pi x over 2. So again, you will have another 2 over n pi. So 2 over n pi here, multiply by another 2 over n pi will give you 4 over n pi squared. Okay, so therefore, okay, now in this example, I'm going to show to you if I just combine this one. Okay, if I just combine the calculation for this, the first function and the second function, so that I will have in this form. Okay, so therefore your n is equals to, so for the first function here, the integration part, so we take the answer from the tabular method. Okay, so you will have this value. So therefore you will have 2 times x minus 2 n pi sine n pi x over 2. Minus minus will give you plus 4 over n pi squared cos n pi x over 2. Okay, so this one is for the first function. So with the upper limit is equals to 1 and lower limit equals to 0. Plus, so for the second function here, this function. Okay, so integrate cos will give you sine. So you will have 2 over n pi sine n pi x over 2. So for this one, your limit will be, so upper limit is 2, lower limit is 1. Okay, so now you're going to substitute the limit. So you will have your an is equals to, so for the first function here, for this function, so substitute x is equals to 1 minus substitute x is equals to 0. So we'll give you 1 minus 2 is equals to negative 1. So you will have negative 2 over n pi sine n pi over 2 plus 4 over n pi squared cos n pi over 2. So this is your upper limit minus with, so the lower limit will be, so when you substitute x is equals to 0 in this equation, so you will have negative, so 0 minus 2 will be negative 2, so negative 2 multiplied by 2, so you will have negative 4 over n pi sine 0 plus 4 over n pi squared cos 0. Okay, so this is for the first function. Plus, okay, for the second function, which is this one. So substitute x is equals to 2 into this function, will give you 2 over n pi sine n pi minus 2 over n pi sine n pi over 2. Okay, so now we are going to simplify whatever function you have here. Okay, so as for this one, you cannot do anything, so leave it in this form. Okay, so okay, for this one here, if you have sine n pi or cos n pi, so you can just leave as this one. But if you have cos of negative n pi over 2, so you need to simplify to be cos n pi over 2. If you have sine negative n pi over 2, so this one is equals to negative sine n pi over 2. Okay, so please remember this one, you might use it. Okay, so for this example here, since you just have sine n pi over 2 and cos n pi over 2, so just leave it as this one. Okay, so what else can you simplify? Sine 0 is equals to 0, so this one 0. Cos 0 is equals to 1. Sine n pi is equals to 0. Sine n pi over 2 is equals to sine n pi over 2. Okay, so therefore your an is equals to negative 2 over n pi sine n pi over 2 plus 4 over n pi squared cos n pi over 2. So this is minus. So minus 4 over n pi the whole thing squared. So plus minus will give you minus 2 over n pi sine n pi over 2. So simplify this one and this one. So therefore you will have your an is equals to negative 4 over n pi sine n pi over 2 plus, so as you can see here, this is 4 over n pi the whole thing squared, and this one is also 4 over n pi the whole thing squared. So I can factorize it. So I will have 4 over n pi the whole thing squared. So we will have cos n pi over 2 minus 1. Okay, so therefore this is your an. Okay, don't worry if you have a long equation for your last answer. It's possible to have that. Okay, so now you already have your a naught and an, and since this is an even function, you know that your bn is equals to 0. So you need to state here your bn is equals to 0. By writing this one, you get 1m. Okay, so please remember, when you know that that is an even function, so write bn is equals to 0. Or if the question already state that given that the function is an even function, okay, so you don't have to sketch. Okay, the clue is for you to know that your bn is equals to 0, then just calculate your a naught and an. So now you already have your Fourier coefficient, which is a naught, an and bn. So therefore you can write your fx, Fourier series expansion. So your fx is equals to a naught over 2 plus summation n is equals to 1 to infinity an cos n pi x over L. Your L is equals to 2. Why you don't have the bn at the back here? Because your bn is equals to 0. Okay, so that's why you left with a naught and an. Okay, so therefore you will have, since your a naught is equals to negative 1 over 2, so you will have negative 1 over 4 plus summation n is equals to 1 to infinity. So what is your an here? So your an is the whole function here. So write it here. Okay, and this whole function here need to multiply by cos n pi x over 2. So therefore you will have, so I'm using the bracket here. So negative 4 over n pi sine n pi over 2 plus 4 over n pi the whole thing squared cos n pi over 2 minus 1. So close bracket for this one and another big bracket here for the first bracket. So this, the whole an here need to multiply by this one. So you will have cos n pi x over 2 because your L is equals to 2. Okay, so therefore this is your Fourier series expansion for this function. Okay, So we are done with even function. So in my next video, we will proceed with the last function, which is an odd function. How to find the Fourier series expansion of odd function. Okay, so I see you guys in my next video. So please try to do the exercise and the homework that I give to you in the notes. And if you have any problem, please let me know so that I can guide you to get the answer. Okay, so stay tuned and I'll see you in my next video.